So now that we have actually talked about how forking is done in Linux, let us go to the sweet parts where you had some trouble during the lecture. So I said repetitively that there is no concept of threads in Linux. It is just a task, and that means that there are no special scheduling semantics or data structures to represent threads basically in Linux. So they are just like any normal process, and that each thread has a unique task struct and appears to the kernel as a normal process. And they just look like basically processes that share some resources such as address space or with other processes. Okay. In Windows and Solaris, threads are actually called lightweight processes, and they are basically different. I mean, it's a very different mindset. You have a process, and you have a thread or a lightweight process, and a thread is much lighter as an abstraction compared to a process. This is actually some benchmarking of spawning threads, creating processes versus creating threads in Windows 7 on a pretty good machine. I mean, an i5 3.2 gigahertz machine, so it's not that ancient. And you can see that creating a process on average takes around 13 milliseconds, while creating a thread takes on average 0.03 milliseconds. So the time required to create a process is 340 times on average the times required to actually create a thread. And that is a completely different mindset compared to Linux, because in Linux both threads and processes are just the same, while in Windows you really have, on Solaris, which is kind of dying, in Windows and Solaris you really have to think when do you want to thread and when do you want to spawn a new process, because the cost and the as in time required to start such a thread or a process is very significantly different. And basically, this is a huge difference. And here comes the Windows versus Linux. What is the difference between the implementation of these two? But let us first ask a question, which is basically compare the implementation between Linux and Windows if you're writing a multi-threaded program, assuming that you have a process that consists of 4 threads. So if you have a process that runs basically 4 threads, in Linux it will be implemented differently compared to Windows. Can you think of how they are different? So let's go back to how threads are created in Linux, just to basically finalize this. And these are basically the flags that the clone flags that are used to basically set up the way that the threads are created in Linux versus, so using these using these flags, you control how a thread is actually created and what is shared between the different threads, what is shared between the thread and the parent. And if you're going, for example, for a vfork, so this is a clone vfork flag that basically tells the do copy call to basically start vfork instead of a normal fork, and so on. So these are basically all the flags that you need to parameterize how your thread creation works in Linux. Okay, now this is where people had troubles. Kernel threads. Let's talk about kernel threads in Linux, because they are just quite simple. I mean, all threads are equal in Linux, and that basically means that kernel threads are not really that different in how they are created and how they are managed. In Linux, I cannot emphasize that more. And the kernel thread is basically a standard process that exists solely in the kernel space. And it is basically something that is used by the actual kernel to do things, to run actually kernel specific tasks. So it is in the context of Linux, when we talk about kernel threads, then we are actually talking about threads that do stuff for the kernel and has nothing to do with user space threads. And this is again where kernel threads are actually implemented. It's in kthreads.c, and there you basically have quite a good description of what this does and how does this differ from a normal threads. And you have basically kthread create on node for that. Okay, so what is the difference between kernel threads, user level threads, and kernel supported threads? And I never talked about kernel supported threads before, but let's just say that it is a complete mess. Let us start by the very easy ones. There is the concept of user level threads, which are also called in some textbooks green threads. And these are basically threads that are completely unknown to the operating system. These are the threads that we talked about in the lecture that basically do not appear to the operating system in any way and do not affect, the operating system is completely unaware that these threads exist. And you can make a hack using upcalls that to basically make the kernel schedule threads. And this is what I talked about in the lecture, that you might want to actually want the actual thread scheduling as an application for yourself. And this is in the book in section 4.8.2. There is a description of that. And this was the main way to do threading before. There was nothing else compared to this. And it sucked. It really sucked because it required a lot from the programmer to actually get the thread scheduling to be correct. Okay, now that we are done with these, and let's talk about kernel threads. And well, let's say that they are, in the context of Linux, they are mostly operating system related threads, and they just do operating system related stuff. Remember, for example, when we talked about when a thread dies or when a thread goes into finished state, you need a kernel level thread to basically handle the actual cleaning up of everything. But, and this is, as I said, it's a mess. This is also used in many systems to actually have kernel supported threads. And in many systems, you basically do not differentiate between the kernel supported threads and kernel threads, as in terminology wise. So what are kernel supported threads? Again, this is a mess more than the previous mess. What the kernel supported thread doesn't not just depend on the operating system, but also on the threading library and on the programming language. So it's something that basically tells you that these threads the kernel can schedule. Basically, they are user level threads that the kernel can schedule.